Yesterday we looked at how to do the advanced GCF factoring, and so what we're doing today is I'm going to even take it a step further. And what was cool about yesterday was I grouped them into parentheses for you, and then it was easy to see, right, that it followed this pattern, like this pattern for the most part, right, where the two front things were different numbers, but the two second things were the same, so we would pull out the B, and then what was left was A plus C, right? Remember that yesterday? So unfortunately, what we're doing today is the first part of what we're doing today is I don't make the parentheses for you. I don't group them for you right away. You have to put your own parentheses and put them together. So there's two types of problems we're going to do. I wanted to show you the GCF ones yesterday to help you out with today. And so the first half of what we're doing is we're doing GCF, but you have to group them yourself. And the second part of today is looking at advanced difference of two squares factoring. So what I want to go over quickly right now is just how to tell the difference between the two types of problems. So for a GCF problem, usually what will happen is there's nothing that's squared in the original problem. So if you look here at the examples here in 1 and 2, see how none of them have a squared? They don't have an exponent of 2, right? Typically, sometimes you might end up with one thing that might have it, but typically they're not squared. Okay, and so for these 1 and 2, that tells you for sure that this is going to end up being a GCF problem because nothing is squared. Now, if it's going to be a difference of two squares problem, and here I wrote the equation here on the top so that you could remember what a difference of two squares is. Remember, it's when you have two things that are being squared with a minus sign in the middle, and then you can split it up by going a plus b, a minus b. Okay, so when it's a difference of two squares problem, you're looking at the original problem, and you have at least two things that are squared. Okay, so one thing might still qualify for a GCF, but if you have two or more things, it's probably going to be a difference of two squares problem. Another thing that's special about the difference of two squares is that when you write it out to simplify, you're going to still be having to group them yourselves. So you're going to have one squared term, so one thing that's by itself, minus a parenthesis that has three things in it. And so that's how the setup for a difference of two squares is different from what we did yesterday. Remember yesterday, typically for the most part, there was only, you had two sets of parentheses with two or three things in each of them. Well, for a difference of two squares, you're always going to follow this pattern of having one thing that's squared and then another parenthesis that has three things in it. So the best thing we can do right now is let's go to an example, and just like we had established already, this 1 and 2 examples 1 and 2 are going to be GCF problems because there's nothing that's squared in them. So starting with number 1, we don't have the parentheses made for us. Remember, that's what I've been telling you, is that we're going to have to make the parentheses ourselves. So the way I would do this is I would group things that have similar letters. So sometimes they'll be in order and sometimes they won't, but let's group things that have similar letters. So looking at this right off the bat, maybe the let's see, AB and minus 2B, they have the same letter. They both have a B in common. Let's throw a parenthesis around them. Then I have a positive AC minus 2C, right? So this plus is just here just to remind you that this AC is positive. So let's group it like this. So the plus goes away because the AC is positive, so remember I can also represent something positive by just taking out that plus. We already know that this AC is positive without me writing plus or not writing it. Okay, so next step would be just like what we know how to do. Let's pull out the GCF from each parenthesis. So in this parenthesis, I have I'm pulling out a B. That's what they have in common. So I have a B, and then I have what's left in there, a minus 2. Okay, in this one I have an AC minus 2C, positive AC. So let's pull out a positive C. So positive C, I want to take that plus sign with me. Positive C, what's left in there is an A minus 2. And the reason why I want to pull out that plus C is so that I remind myself it's positive, and because remember, like what we did yesterday, we're going to have to use this sign in front of C to tell us when we pull out the GCF. So now the problem, we got lucky, we grouped them correctly. So we know we grouped them correctly because the parentheses are exactly the same, so we don't have to go back and try again. This is now, what we've created is a problem just like yesterday, where they both have an A-2 in common, right? And so we write the A-2 out here in the front. And then what's left is a B plus C that we group together. So final factoring for this is A-2 times B plus C. And if you want to correct that yourself, all you got to do is just FOIL them or multiply them together, and you should get back to the original problem. Okay? Let's look at number 2, and let's, again, first step is to group them ourselves, okay? And remember to keep the, the signs are really, really important, otherwise the problem is going to get weird. So let's see. Okay, if I group them like this, let's see if this is going to work out. Okay, so for right now I took out the plus because this 8 is positive, but if I want to, when I pull out their GCF, I'm going to take out the plus with it, okay? So here we go. In this first set of parentheses, let's see if this is going to work out. They both have a 3 and an H in common. So what's left inside there is a K minus 4, okay? Let's see with this guy. In this one, what I have is they both have a 2 in common, and so let's pull out a positive 2, or actually, okay, let's pull out a positive 2. So what's left is 4 minus K. Okay, so we're kind of close actually, right? So let's see what's wrong here. So let's go ahead and rewrite this parenthesis. These are one of those weird -1 type of problems, okay? Let's rewrite this one so that the K is first. So the first thing doesn't change, plus 2 is still there. So if I wanted to write this so that the K is first, this is -K. That's a positive 4. Okay, so look at the parentheses. They're almost exactly the same, except that they have their opposite signs. So remember what I told you to do when that happens? You're going to multiply a -1 to everything, starting with the 2, so that we can get the signs to be the same. Okay, so when I do that and multiply a -1 through, this first term stays. First term in parentheses stays. This positive 2 is going to turn into -2. That -K is going to turn into positive K, and then that positive 4 is going to turn into -4. Now these two guys look exactly the same. Okay, GCF is K minus 4, and then I have 3H minus 2 that's left over. So final answer for this guy looks like that. Okay. So don't forget our rules from yesterday, because if you forget our rules from yesterday, then we're going to end up with some trouble. Okay. So you can't forget our rules from yesterday. Let's go ahead and let's start working on the other type of problems, maybe the difference of two square problems. Okay, guys, let's look at these next two examples, and we know that this is not going to be a GCF problem, and it's probably going to be a difference of two squares problem, because if you look at both of these questions for number 3 and 4, you'll see that it meets the criteria of it having at least two things that are squared. So like in number 3, I have this h squared, and I have this 4k squared. I have this is squared, this is squared, that's squared. So all of them have at least two things that are being squared. So that tells me it's going to be a difference of two squares problem. So here is how we set these up. So what you want to remember is you need to have at least one parenthesis that's going to have three things, and then one term that's just going to be by itself, and that term is going to be something that's squared too. So looking at this, looking at number 3, if you have to have one thing that's squared and then another one that has three terms in it, let me show you how to form the one that has three terms. So the one in three with three terms will depend on, it really depends. So my recommendation is to look first at all of the things that are squared, so in number 3, here and here, and pick the one that's not negative. So the first thing would be to look at the things that are not squared and pick the thing that's not negative. In this case, in number 3, it's the h squared, right? So the thing that's not negative, you want to keep it first. Okay, now once you've figured out what the thing that isn't negative is, look and see if there's any letters that match up with it. So I'm looking, this one has a K, this one has an H, nice. Okay, so I'm going to write that right next to it. Okay, so now I have an h squared, I have an h, and to complete the third thing, so you're either going to have a parenthesis that has three things or a parenthesis that only has one thing in it. So since you already have two things in here, you're going to have to assume that this is going to be the one that has three things in it. So you're either going to have a parenthesis that has one thing in it or something that has three things in it. This already has two things, so it has to have a third thing to complete it. So to complete it, let's look for let's look for a number that's maybe like the loner number here, maybe. So let's try 4. Let's put the 4 in there. And now I have three things in there. The only thing that's left in here now is a minus 4k squared. Okay, so obviously there's nothing you can do to this negative 4k squared. There's nothing to factor it with. But you can factor h squared minus 4h plus 4. And the way you can factor it is by using our friend the box trick here. So I go 1 and 1, 2 and 2, and I know that both of my parentheses are going to end up having to be the same sign. What sign is that? Do you guys remember? They're going to be minus signs because the first sign is a minus, so it's minus, minus. Remember, because the back sign is plus, we're adding to get the middle number. 1 times 2 is 2. 1 times 2 is 2. So if I add 2 and 2 together, I get 4. So yes, this is the pairs, okay? So I pair them going across. Excuse me. So I get h minus 2, h minus 2, okay? And do you guys agree with me that h minus 2 and h minus 2 is the same thing as writing this? H minus 2 times h minus 2 is the same thing as h minus 2 squared. So now what happens, you guys, is I basically have a difference of 2 squareds. Look, I have two things that are squared with a minus sign in the middle. And so the way that you would expand this out further is you'll end up with two parentheses. One's plus, one's minus. And the way that you would write this is you would go the first thing, which is h minus 2, and then the second thing, square root of the second thing would be 2k. Then the first thing again, h minus 2, square root of the second thing would be 2k. And so that's what you would get for a final answer. So this one's a little weird. It requires really like a lot of different factoring techniques. So that's why we're calling it advanced multi-step factoring. So you can't forget all the things that we've done with factoring or you're going to be in trouble. Let's go ahead and try our last example, number 4. And I encourage you guys, because this is really interesting stuff, to please write your questions on the side so that we can go over them in class, okay? So here we go. Let's go through the same process here. It's a difference of two squares problem because I have at least two things that have a squared next to them, right? I have the 9p squared here, the 4s squared, and then the and then the t squared. Okay, so the way we figure out what goes first is we look for out of the squared things. So 1, 2, and 3, which one is positive? The 9p squared is positive, so I'm going to put that one first. Okay, and so what's left is a negative 4s squared and a negative t squared. So, is there any other letter that's p here? I have an S, I have an ST, I have a T. There's nothing else that's P. So this guy is going to be the loner this time. So our single term is going to be first this time. Okay? And so what we want to do now is let's group everything else together. Negative 4s squared minus 4st minus t squared. Okay? And so I'm missing the key sign in between here. What sign am I missing in between here? What's the important one that I need? Let's scroll up so that we remember. The important one that I need is this minus sign. So let's pull out a minus sign from here because I already have a negative 4s squared right there. So if I pull out a negative from the 4s squared, I'm going to have to pull out a negative from everything. So if I pull out a negative from this guy, it's going to change the sign to positive. If I pull out a negative from this guy, it's going to change it to positive. So when you pull out, the idea of pulling out a negative also means you can distribute a negative 1 into a parenthesis, but you can also pull it out. Either way, you're going to have to change the sign, whether you're putting one into everything or you're going to add one or you're taking it out. Okay, so that was that idea, and the reason again why we did that is because we have to have at least one thing that's by itself. So we established it was the p squared because there were no more p's here, and then there has to be a minus sign separating the two. So at first there was no minus sign here, so I had to pull one out, and if I pull one out from the first guy, I have to pull one out from everything because they're all attached. One more thing I want to bring up is you know that this was a good match, you guys, because all the letters kind of connect here. So there's an S and an S go together, a T and a T, and since these S and T's are together, then that means that these three have to go together because they all have kind of similar letters. Okay, so just like what we did in the other problem in number 3, let me scoot it over so you can see it. We've got to factor this guy out. Okay, so 4, let's go 2 and 2 maybe, 1 and 1. Remember, we're adding to get the, because this is plus, we're adding to get the same, to get the middle number. This 9p squared just drops down. So I end up with, this works 2 times 1, 2. 2 times 1 is 2. If you add them, you get 4, so that's right. So I end up with 2s plus 1. 2s plus 1, okay? Plus because the back sign's plus, so they're both the same. And then the first sign is plus, so that's how you know that you get plus plus, okay? Rewrite it so that it looks like this. Okay. And then by difference of 2 squares, the way that this works is it's 2 parentheses. And you end up with, one's a plus, one's a minus, okay? So square root of 9p squared is 3p. So 3p and 3p. And then I end up with 2s plus 1. And then 2s plus 1. Okay? Sorry, there we go. And the reason why I put that in a parenthesis